Hello and welcome back to Introduction to Number Theory. This time we'll talk about invertible elements of the ring consisting of quadratic irrationalities with integer coefficients. We denote this ring by z of square root of a. So what does it mean to be invertible? It means that if we divide 1 by z that belongs to this ring, then we should also get a number from this ring. When we say number, we mean real numbers, since this ring is a subset of the field of real numbers. So, as usual, we use the conjugate to z, which is x minus y square root of a, just to transform the fraction 1 over z into a fraction with integer coefficients. And in this form, as on the slide, we see that the denominator of this fraction is an integer number. So let's denote this denominator as usual by d. We understand that in order for 1 over z to be a quadratic irrationality with integer coefficients, x and y must be divisible by d. I remind you that d is the denominator. It is x squared minus a y squared. But since x and y are both divisible by d, then x squared and y squared should be divisible by d squared. So we can conclude that x squared minus a y squared is divisible by d squared. But x squared minus a y squared is simply d. This means that d must be divisible by d squared. This means that 1 must be divisible by d, in the ring of integers, of course. Well, from this it follows that d is either plus 1 or minus 1. So once again, in order for z to be invertible in the ring of quadratic irrationalities, z of square root of a, then its norm x squared minus a y squared must be equal to plus or minus 1. So these two conditions are equivalent. Well, this leads us to a very famous equation called the Pell's equation. And it is an equation where x squared minus a y squared is equal to 1, not minus 1. And if x squared minus a y squared is equal to minus 1, then it is something jokingly called the minus Pell's equation, and is also interesting, but not as interesting as the Pell's equation itself. Let me just point that in this equation, x and y are the unknowns, and a is a given integer number, which is not perfect square. I just need to add that, well, as it is known that, John Pell is a famous mathematician by all means, but as far as I know, he had very little to do with this equation, so it's some sort of a mistake that is called the Pell's equation, but nevertheless the whole world knows this equation as the Pell's equation, and also we use this name.